So this is lesson 1 from chapter 18, and we're going to look today at integration by u-subs. Now, it might not seem like it, but so far a lot of the questions have been chosen, have been very carefully hand-picked to make sure they integrate very nicely. In these last 2 chapters we're going to look at things to help us solve problems where the integrals are not so nice. And the expectation is for this chapter though that you do recognise this integral. So if you have something that's clearly the derivative of the bottom, then we should recognise this as the ln of the absolute value of f of x plus c. We use the absolute value, or the modulus to use the AICE term, to make sure that the ln function isn't negative. And we're going to look at questions like this. Now, one problem that a lot of students make is they try and distribute here. Now, you're not allowed to distribute here if this has any power except for 1. So with this being a square root, this is clearly to the power of a half. So we can't do that. So I guess one of the things we're going to be looking at is how do you integrate things that are products of each other. We know for differentiation the product rule, but we haven't really come across a method for integration. So for the first question, this one we can't distribute in here because this is to the power of 7. Normally they're going to give us part of the question some substitution. So they've told us let x equal u plus 2. Now I rearranged this for you just to see why they actually gave us this. So if we subtract 2 from here, then notice what's inside the parentheses is actually u. So if we had to try and create something for this, our own substitution, we could always say let u equal the thing that's inside the parentheses to make this question easier. Once we've done that, we're going to try and substitute everything in terms of u. So x is just u plus 2. Now if we do put u plus 2 here, we get u plus 2 minus 2, which will just simplify to u. And we're going to try and find dx. Now as we have an equation in terms of x and u, if we differentiate, we could get dx by du. And then if we rearrange that equation, then we can solve for dx. Now if we go ahead and substitute, as I just said, then we have a question now that we can actually work out. This time we can distribute, because it's just u to the 7 times 2, u to the 7 times u. Then we can just use our normal rules of integration now, increase the power by 1, divide by the new exponent. And also, as this is an indefinite integral, one with no limits, we should be putting a constant at the end of this question. Also, this is in terms of u, but our original question was in terms of x. So just like when we did u-subs for trigonometry, at the end of a question, you need to make sure that you substitute back. Now, there are some key steps that we actually followed when we were doing those questions. So to summarise, the first thing that we did is we have to use the substitution provided. Just a reminder, if you use any other method than the method stated in the question, you automatically get 0 for that question. Differentiate the expression and then solve for dx. We then substitute all the terms and make sure that the integral is in terms of u and simplify. We then need to make sure that we integrate. We then got to substitute back so your answer is in terms of x. And also don't forget at the end of the question to put plus c just to finish that question off. Now for our second example, let's look at x times the square root of x plus 1, which is the one we talked about earlier. This was the one that said it's difficult to do to begin with. They've given us a substitution, so following those steps, first thing we need to do, differentiate that. So dx by du, differential of u squared is 2u, differential of negative 1 is going to be 0. And then we can start substituting in. So where it says x, I'm going to put u squared minus 1. Where it says x, I'm going to put u squared minus 1 plus 1. And if I rearrange dx by du for just dx, then I get 2u du, which I can substitute in. Now hopefully you can start to see why they've actually given us that as our substitution. If we get this now, these are going to cancel out, so I'm just going to get u squared. But notice the square root of u squared is just u, so I have something that's much simpler. So I can rearrange these things. I can bring the 2u to the front. This is just u. And actually I could probably just multiply this straight away, 2u squared, and then times by u squared minus 1. So now I'm substituting in, we've got to try and simplify. So 2u times u squared is 2u to the 4. 2u times negative 1 times u is negative 2u squared. And then go ahead and integrate as normal. Increase the power by 1, divide by the new exponent. Then we're going to substitute back for u. So if x equals u squared minus 1, then if we add 1 to both sides and then do a square root, we can solve for u. Oops. And then we should be finished on this question. Now, somebody did remind me actually, and I forgot to change it. On this previous question, we could also simplify 2 over 8 at the end of this question. So after you have substituted, just make sure there's nothing obvious there that you can also simplify. I could take an x plus 1 to the power of 3 over 2 as a factor as well, possibly here, the lowest power. And I could have done the same on this question as well. I could have taken x minus 2 to the power of 8 as a factor, but I don't think that's particularly important at this step.